Think about your sense of touch. You can pick up an egg without crushing it, or grab a hammer without dropping it. That fine-grained feeling is something robots are famously bad at. Their handshakes tend to be either wet noodle or car crusher, making every introduction an awkward first date. But what if a robot could get a real feel for things by using light? A recent paper from a team led by Yan Fan explores a brilliant way to give robots a more human-like sense of touch. The big problem with robot grip has always been the sensors. Traditional tactile sensors are often rigid, metallic things glued to the outside of a finger. They're fragile, expensive, and can break if you, say, accidentally slam a drawer on the robot's hand. Another common workaround is to just guess the grip force based on how hard the motors in the joints are working. This is clumsy at best and potentially dangerous at worst, especially for prosthetics or robots working alongside people. You don't want a robot arm that handles a person's shoulder with the same delicacy it uses to tighten a lug nut. So, this team built something different. They created a soft, flexible robot finger made of silicone, much closer to our own biology. But the genius part is what's inside. They embedded a series of flexible optical fibers, called waveguides, directly into the silicone. When the finger presses on something, bends, or twists, the whole structure deforms. This stretching and squishing changes the path of light traveling through those internal waveguides. At the base of the finger, a simple camera constantly watches the pattern of light coming out of the fibers. A machine learning algorithm then translates these subtle shifts in the light pattern into a rich, detailed map of pressure, shape, and texture. And it worked beautifully. Their system was sensitive enough to handle incredibly delicate objects, like a piece of tofu or a single berry, without causing any damage. It could also identify the shape of an object by touch alone, even when blindfolded, so to speak. Because the sensors are embedded, they're protected from the outside world. The finger can be bent and stretched, but the light-based signals remain stable and reliable. This also means it doesn't need constant recalibration as the material ages, which is a huge maintenance headache with other sensors. This is a big deal because it makes advanced, gentle robots much more practical. For prosthetics, this technology could allow a user to shake hands with a perfectly normal amount of pressure, or pick up a wine glass without anxiety. For cobots in factories or labs, it means they can safely hand tools to a human colleague without needing a giant safety cage around them. It's a durable, low-cost, and elegant solution that moves us a step closer to robots that don't just compute, but can actually feel their way through the world. Me when my robot finally learns the difference between handshake and bone crusher. So, what's the first delicate task you'd trust a robot with this sense of touch to do? Let us know in the comments.